Alright, my name is Ryan Milburn, and we're going to learn a little bit about the universe today. We're going to learn about a phenomenon known as gravitational lensing. So what is gravitational lensing and when does it occur? First, there's a couple of things that we need to understand. Gravity is amazing, and it doesn't only bring us down to the Earth or keep our orbit with the sun, but gravity actually shapes space and the fabric of space. As we can see here in this diagram, when you have an object in space, the space-time actually curves around it. This allows for light to also follow that space curvature. Another thing that's necessary for gravitational lensing to occur is you need a straight line between a massive object such as a galaxy, a black hole, the observer, and then you have a distant object such as a star. And that'll be explained a little bit better in this next diagram. So we have the observer, we've got the gravitational lens, which occurs because of the black hole or the galaxy, and then we have the source of light, being the star. So what happens is it's a straight line, so we can't exactly see the star where it's at. But because of the curvature of space, we're going to see this light at different points. We're going to see it here, we might see it over here, we might see it up here, and we're going to think that the star actually is right here, here, or here, but not right behind this massive object. These are called quasar stars. Sometimes you can see up to 3 or 4 at a time. You think they're the same, they're different stars, but they're actually the same star due to gravitational lensing. Another important part about lensing is that it actually magnifies it. That's why it's called a lens. It makes it appear closer than it actually is. Another cool thing about gravitational lensing are Einstein rings. He was one of the first to discover gravitational lensing, as with many other things in cosmology. What happens in Einstein rings, how they occur, is the object is exactly behind that black hole or galaxy, right at the center of the axis, and you actually get the light all the way around. One example of that, this basketball obviously doesn't have as much gravity as a black hole or anything, but if we had the observer, let's say on the wall, we've got this light, this is the star, and here's the black hole. You can see how you're able to see the light all the way around it. That's pretty much how gravitational lensing works. Obviously, we don't have the magnifying effect due to the scale right now. This is a little bit about gravitational lensing.